Live from the Icebox Studio in Montgomeryville, Pennsylvania, it's the Bill and Corey Show.
I'm Bill.
And I'm Corey.
Welcome back. Another episode. This is going to be fun. We got a lot of fun things to play with. Of course, if you got any questions, you can YouTube chat, something like that. You don't have to type the way I type. Some people, whatever.
You can do this one if you want.
Yeah, you can do what people do.
Whatever's
much
easiest.
quicker.
Yeah,
Anyway,
on the phone maybe.
First question. We had a customer who had some pressure stability issues with the Model 3030 regulator. Now the Model 3030 regulator, it's our high delivery. It's one of our high delivery pressure regulators. So I'm going to explain a couple things about how regulator works, and then we'll get on.
And that one's typically used on the types of cylinders that are way above 3,000.
We sell a lot 3,000, but this will have 1,500 psi deliveries.
Yeah.
One of the ranges 2,500 psi. So yeah, when you need that really high delivery pressure. Now this is a standard two-stage regulator without any gauges or anything else in it, but this is the body of it. And our regulators and pretty much everybody else's are about the same. And it has the bonnet, which has the spring, compresses on the diaphragm. This is the diaphragm. And then you've got a valve mechanism in there to help control the pressure. Now, these kind of regulators are typically good for about 500 psi delivery pressure. There's different ranges. So, above 500, then you got to go to a different kind of regulator. So you can see this is actually want to kind of zoom in on that one.
There we go.
Yeah, that's a little diaphragm. This one's stainless steel. It's kind of thin. It gives you some flexibility against the pressure.
It's thin, and you can actually bend it with your fingers. It's that thin.
Yeah, that's actually the reason why it works. What happens is you have a little force balance with a regulator.
Is that a Star Wars reference? The force balance.
The force. Yeah. So you've got spring is going to provide force on this side. And that's what your adjusting knob will push on against the diaphragm. And that's how so you've got, the pressure is pounds per square inch.
Yeah, it's coming up. The pressure's coming up underneath the diaphragm.
Yeah, so you got pressure here, gas pressure.
And the spring.
And you balance it with this mechanical pressure of the spring. And the more,
the more it pushes down, the more pressure it'll let through.
The more force it has.
Yeah. Okay,
so, and it's nice to have, this is springy. We're not going to use this one again. It's spring. See, it has to have some springiness.
It does.
So you can adjust the pressure, because it goes in and out and stuff. So above.
I mean, like a think of a soft diaphragm, or your diaphragm, and it moves. They move.
Yeah, it moves. That's how we adjust the pressure.
Yeah.
So you get higher than 500 psi. This isn't going to hold it. And if you went with thicker metal, then it wouldn't be springy.
It wouldn't be flexible. Yeah.
So you got to. There's balances here. So this is the 3030, and you want to zoom in on this one again. This is a piston regulator, and that's what you're using instead of diaphragm. It's this little piston.
Yeah, it's a little piston.
And it's got O-ring seals on there.
Put that in a small car engine. It'll work.
No, just. And it'll also have a spring pressing on it too. Now this is so. Reason why you do that is a couple reasons. One is because this isn't going to be able to hold the high pressure, and then you've got different areas. So this diaphragm is 7 times the area of this piston, and you can zoom out. You don't need to have as big of a spring to push on it, because you get to a point, you get springs, and what are you going to do? We get like a car spring or something like that.
Pogo stick spring.
Yeah, pogo stick. There's limits to your spring size, and then mechanically to try to turn it in, you got a screw to give you mechanical advantage. So for the higher pressure regulators, a lot of times they go with the piston, and a couple of reasons why you don't get as sensitive pressure is because if you get a little, this is the kind of spring you're doing here. If this is a mechanical thing and you're turning it in. So if you have a slight fluctuation in pressure here, it's going to have a bigger impact on the smaller diameter pressure,
square
the
inch.
piston versus, so this is 1/7 the size. So if you have the same spring pressure, you're going to have, it's not going to give you the tight control.
Yes.
Because it's a small area. And it also has O-rings, and this looks like it's like a Viton and then a Teflon in there. But they can stick a little bit too. So yeah, if you really want smooth, it's a trade-off.
It's a trade-off. You're either get higher pressure, but at the same time, if you're at, if you're getting 2,000 psi, even plus or minus, even the gauge plus or minus 2% is a big.
Oh yeah, well actually with a gauge, 2,000 psi gauge where they're operating 550, the gauge is plus or minus 40.
Yeah,
and they're getting like plus or minus, they're getting 20 psi difference.
Okay.
Now for high pressure regulators, there's a different. Some people, now this is a really high pressure regulator. This is for...
How high is it?
This can go to 6,000 psi delivery pressure. Wow. So you use this on the really high 6,000 psi.
Yeah, and this one can accept like 9,000 or something?
It can be 10,000.
10,000 in.
For stainless steel, I think 7,500 for brass. This is their 3060 series.
Yes.
So it's a little hunkier, beefier kind of setup. It's got some really serious washers in here. It actually has, they kind of call it a diaphragm.
It just looks like a big piston to me.
Yeah.
it's a diaphragm piston valve.
Yeah, it's got a, sorry. And this I didn't know how to take it apart, so I kind of mangled up the rubber because I
that was probably going to leak through the diaphragm.
This is one demo thing that we've had for a long time. But I also, I twisted it to pull it out, and it's not good to twist
rubber, soft goods.
It's not good to twist it back and forth. Yeah, you want to zoom in on this? It's a little broken, but you can kind of see pretend this is all one thing. But this is a thick neoprene, so the spring will push, and it has some springiness to it. So if you want smoother pressure control at really high pressures, you should go with the 3060 series instead of the 3030 series. So it's kind of a trade-off. You can't always get everything you want with a pressure regulator. So there's some balance there. And this is more complicated than 3060, so it's going to cost more than a 3030.
There you go. So that's another trade-off. If you want to get, because you get a little bit of both with this one.
Yeah, and some people make with the high pressure regulators. We'll use a piston-based one for the really high pressure regulators there. So that's kind of the breakdown there. That if you want the piston regulator is not good for great pressure control, and if you want to go with diaphragm regulators, if you're dealing with low pressures, a lot of times you'll see a bigger diaphragm because it'll give you a better pressure control at the lower pressures. So this is a mess to clean up. But
so we got some regulator knowledge.
Yeah, so there's kind of diaphragm versus piston regulators. Okay, and then next question.
More of an exciting question than what it seems like, isn't it?
Oh, yeah, actually this question is kind of a stretch for technical stuff. Someone was asking about the availability of the 6190 filter. And there's two different types. We've got this is the 6190 there. That has VCR connections. It's all welded VCR connections on there.
Everything's
That we have in stock. You can order it in an online store or call your customer service rep, get it ordered. If you want to have the other version you get it's more popular, is with compression fittings, and that's March, but that's not the reason why. So we had our vendor who makes the filters brought one down for us to look at. So what's cool about this is this is all welded together, and we can never really look on the inside of this. Yeah.
And now we get a chance to look on the inside of this because there was a slight change in. Oh, I'm sorry, I did. There's a slight change in the filter housing, and they had to reconstruct.
Not the housing, the filter element.
The filter element. The filter doesn't change nothing, but it's just some dimensions of it change, and so they brought it to us to make sure it was okay. And so we got to see the inside of this. So inside of this is the filter element, and it's kind of a little bit surprising because it doesn't seem all that fancy. It's just a filter, but you know.
And that's a Teflon membrane in there, and this is a 0.1 micron filter.
0.1 micron filter, so it's a good filter.
Yeah, and this is rated for 1,000 psi when
Yes.
it's all welded together.
Yes,
So
yes.
it's all welded together. But we had the issue where the people who made this element weren't making. Well, they're making this one obviously, but the one that we previously used, they stopped making that. So we had our vendor had to find a different one of their filter elements. It's the same material, same pore size, all that kind of stuff. It just has to be configured a little differently in there. So.
And so so this one, I mean, springs are involved in this one too.
Yeah,
just
you get
like
springs. Yeah.
just like regularly, you put that piece in.
You put this in there.
Put that in there.
Put the spring on there.
And then some poor guy, I think, has to push this down and then weld it on.
I think they use a jig.
You think they use a jig? I think a guy holds it and then just goes.
It's not gonna work that way.
No,
Don't try that.
All right, no, don't try that at home.
So, yeah, so that's kind of a 6190 filter. So it's kind of fun. We got to take one of those apart.
Filter.
And this is all bagged up. So now I'll get it.
Yeah. So if you guys want to buy this one, it is available. We didn't.
Yeah, the one that's bagged. The pieces we're not selling.
Yeah, no. It's not an IKEA kit.
Okay. Oops, sorry about that. Now we got a lot of props here, so we pull up this. Next question is, it's on this valve.
This valve.
And this, not that valve.
Yes,
this valve. Someone want to know what the stem and bonnet nut materials were for this particular valve, and that's so that's
it's a quarter-turn diaphragm valve.
Yeah. And it's similar to. I'm not taking that one apart. This is the one that we had laying around that was already apart.
It's essentially pretty similar except different handles. That's.
Yeah, it's a lot of it's the same parts, but this is you want to take these parts apart.
Jeez, did you bring a wrench?
Just ready, tighty, lefty, loose.
I know that. Yes.
Yeah, I'll take it out.
Probably loosen it for you.
Oh, you know what? You screw in to get it out.
Oh, it's not righty tighty, lefty loosey.
Well, it depends on what it is. So yeah.
Oh, I see how it works. Okay. All right. Oh, I got you.
So that's the stem they're looking for.
Yes.
And this is the bonnet nut. And the bonnet nut is 303 stainless steel. That's popular for machining.
Stem is 416 stainless steel.
Yeah.
4, and when the 4 is for this guy.
Now Now this is you want to talk about wetted versus unwetted parts?
So there within all valves, regulators, any system, there are wetted and unwetted parts. The meaning of that means parts that touch the gas and gets wet, but you don't want a lot of moisture in your system typically.
No, it's not getting wet. That's just a term.
No, it's just a term. And unwetted parts are parts that never see it. Like for obviously the easy one to look at is the handle is an unwetted part on this because it never sees the actual fluid in the system. So in this case, and correct me if I'm wrong, these things are unwetted.
They're unwetted parts.
They're unwetted parts. But still, it's good to know the material of them, and it's not a bad question to ask.
Yeah, but typically when you look for materials, when someone lists materials for
compatibility.
For compatibility, it's usually the wetted parts. It's not the unwetted parts. So it's sometimes people list the unwetted parts, but
by the time this gets wet, it's already
a lot of problems.
It's already bad news.
But yeah, sometimes you get the question, they want to know what that is for whatever reason.
Some people like to be thorough, and there's nothing wrong with that.
Okay, good, thanks. All right. Yeah, we do have time for your
my question.
Question.
Just a little bit.
Okay. This the last question today, unless someone types something in for us. Can the 819 series flow meter be mounted on a panel from the back? The instructions say the bottom has holes for mounting, but the customer wants to mount this on a panel hanging on a wall.
Well, this was sort of a stroke of luck. I actually recently I designed a panel where we put these on there, facing you like this, even though it's got bottom mount. So a lot of times people will mount them on a bottom plate and use them that way. Yeah. Seen that done a lot, but this one mounted it from the back. And luckily, somebody at this illustrious company, way before I was here, did a project where they mounted mass flow controllers on a panel, and these brackets were left over. There's a short version and a long version. I don't know the reasoning for the two ones, but as you can see, here are the two mounting holes at the bottom. You take this guy, or I don't know if you want to get closer. Want to zoom in on it?
There we go.
There we go. Yeah, you can see them. These are the actual screws holding the bottom on, but these are mounting holes, and you can take this guy, put a screw up in there, mount it, and then you got the two holes in the back to mount it to the back plate. The shorter version, if you're not worried about, if you just want a shorter version, you want it right flush against the panel because, you don't want to push into it, you can, so we have two styles for this. But either one works for mounting it on a back panel. Just screw it to the bottom and mount it in the back.
Now, what kind of panel were you making when you had these?
Oh, I was making a mixer panel. So we put two of these on a panel to float, two different gases, and went actually to a mixing tube, or our mixing, essentially our mixing tube that we use on our rotometers. Actually, it's tubular. It has a element inside it to mix the gases. And so we mounted this on, one up here, one down there, brought them together, and mixing gases for customers. So if you're interested in that sort of things, please contact our illustrious salespeople. Yeah. And we're looking to see if people are interested in something like that.
Yeah, great. So I guess no questions came in from our viewers. So that's all we got for this week. Tune in again next week at 10 a.m. for another episode of the Bill and Corey Show.
Set your VCRs.